Welcome to a basic introduction to fire. This course shall cover the following subjects. What is a fire detection system? System types and terminology, system protocols, questions and final notes, so let's get started. What is a fire detection system? A fire detection system is a means of early indication of a fire within a building in a non-domestic application to a fire-related event by means of electronic equipment. The purpose of a fire alarm is to protect life and/or property. In the United Kingdom, the relevant standards and code of practice is British Standard 5839 Part 1, Fire Detection and Alarm Systems for Buildings. Types of systems and terminology. Systems available are conventional, by-wire, addressable, gas suppression, hybrid, wireless, and aspirating detection. So how does a fire detection system work? The main part to a fire detection system is the control panel. This is the brains of the system. This works in its simplest form by receiving an input and switching on an output. The more intelligent systems will make decisions based upon algorithms and then actions commands to other equipment. These could be simple delays or a sequence of events in a specific order, such as cause and effects, delays, phased evacuation, etc. So starting with a conventional system, this is the most basic fire system. This is where the detectors, call points, inputs, are connected to each zone circuit, and then sounders, beacons, outputs, to each sounder circuit. These circuits are dedicated and wired in a radial circuit, otherwise referred to as a four-wire system. And advantages and disadvantages of a conventional system are as follows, but not limited to. Some of the advantages of conventional systems are: the fire panel and field devices are relatively low cost compared to other systems. You can mix and match certain manufacturers' equipment. Some of the disadvantages of conventional systems are: generally, there is no screen on the panel to display information, just zonal LEDs and labels. There can be a maximum of 32 detectors per zone, and 32 zones available, additional wiring for sounder circuits, lack of flexibility and false alarm management, and very little programming functionality. Next up is by-wire fire systems. Another cheaper but smaller option is the by-wire fire alarm system. This is where the detectors, call points, beams and sounders, beacons are connected to each zone on one radial, referred to as two-wire system. This reduces the cost of installing an additional sounder circuit, saving time. However, the devices are not compatible with conventional equipment. Commonly known detection and equipment is Apollo Alarm Sense, Fike Twin Flex and Savwire. Advantages and disadvantages of the by-wire system are but not limited to. Once again, the fire panel and field devices are relatively low cost compared to other systems. All equipment can be positioned on the same cable, reducing the amount of cable and installation labor. Some of the disadvantages of by-wire systems are: generally, there is no screen on the panel to display information, just zone LEDs. There can be a maximum of 25 devices per zone and 8 zones available this time. If something happened to the circuit, you could potentially lose both detection and sounders. Lack of flexibility and false alarm management, little programming functionality, a maximum cable length per zone, 500 meters, and you can't mix and match device types. These are manufacturer specific. Next is addressable or analog addressable systems. This is where all the equipment that is detectors, call points, beams, sounders, beacons, and interface modules connect to each loop circuit, also referred to as a loop system, featuring 1 to 8 loop panels, 126 to 255 devices per loop, 2,000 meters of cable per loop, extensive number of zones. The system also gives a unique address and location text, with panels being networked together and repeater panels. A range of peripheral devices such as additional zone or relay cards. Integration with third-party equipment with complex programming. Advantages and disadvantages of addressable systems. Some of the main benefits of addressable systems are more detailed and accessible information regarding fire and faults due to its display or printer. The system can pinpoint which address has detected a fire with both device and amp. Zone text location. False alarm management, more sophisticated detection methods, and flexibility. Software enables more advanced features such as complex cause and effects. Networking panels together enables larger systems. Additional peripheral equipment can be added, such as conventional zone boards, sounders. Some of the disadvantages of addressable systems are: require more expertise to install and program correctly, increased price of panels, detection and peripherals. Equipment is protocol and manufacturer specific. You can't mix equipment. Next, we have hybrid fire systems. Hybrid fire alarms consist of the usual parts of an addressable fire alarm system. The hybrid element brings wireless flexibility of adding additional wireless equipment onto a hardwired system where installation is difficult. No wiring is required. Instead, they use radio signals to communicate with the control panel via a translator hub device, which is connected to the loop cable. This results in minimum disruption of the premises during installation and no sight of the cabling. These hybrid fire alarm systems are ideal for business premises, industrial units, heritage buildings, schools, museums, hotels, castles, churches, and pretty much becoming across the industry. An alternative solution. With up to 32 wireless devices per loop interface with a 100-meter range, you can have up to 10 translator interfaces per loop, which are loop-powered, so no additional power supplies are required. Built-in short-circuit isolators for system integrity and bi-directional wireless communication with dual-channel redundancy. As with addressable fire systems, the benefits of wireless make the installation quick and avoiding disruptions. However, the cost of the equipment up front is generally greater, and battery replacements should be considered having a 5 to 10 year battery life subject to usage. Similar to hybrid fire alarms, a fully wireless system have their own control panel along with any boosters and field equipment. No wiring is required. Instead, they use radio signals to communicate with the control panel directly, unlike the hybrid units. They come as small simply system with 32 devices to multiple networked systems with up to 8,000 devices across large sites. Benefits of wireless and hybrid systems. Some of the main benefits of wireless systems is the flexibility and quick installation time, combined with false alarm management features. However, upfront costs of the equipment and battery replacements should also be considered, and it is recommended that a radio survey be carried out before installation to ensure adequate signal strengths can be obtained. So, what is gas suppression? Gas suppression systems extinguish fires by removing the oxygen content to below 15%, where most materials do not burn, or chemically cool the flames by removing one of the elements from the fire triangle. They are activated by a smoke detection in the normal way, with a conventional or addressable sensors that detects the early presence of smoke. These panels can be a mixture of conventional and analog addressable. However, the panels, peripherals and addressable equipment will be manufacturer and protocol specific. What is very early warning smoke detection? Aspirating smoke detection is basically a very intelligent smoke sensor, sampling the air within a protected area in the form of a panel and network of pipe run throughout. These will normally be connected to a fire panel to provide full reporting to the system via a zone connection or interface module. Closed, open and managed protocols. So what is a protocol? The protocol is a language used by a fire alarm system for communicating between field devices. These are only applicable to some two-wire, addressable and wireless systems. Some of these protocols cannot be mixed with other equipment, hence the term closed and managed. Open protocols have a little more flexibility. Both the open and closed protocols have advantages and disadvantages. What is a closed protocol? The system installer and manufacturer usually lock down this type of fire alarm system. By installing closed protocol systems, this can limit other organizations to whom have access, relevant training and support from the manufacturer to provide and maintain such systems. There can also, in some circumstances, can add additional cost implications to the end user as a result. You may often hear people mention obtaining passwords and codes to gain access to such systems or unable to program the systems with the relevant software. What is a managed protocol? A managed protocol is very similar to a closed protocol. However, usually the manufacturer will operate a network of approved companies who receive training and additional support to sell, install and maintain the equipment, normally with annual sales targets to remain an approved company. Again, in some circumstances can add additional cost implications to the end user as a result. What is an open protocol? An open protocol system is when a fire alarm system is unlocked, and any third-party company is then available to install and maintain the system. This is excellent if you want full control over your fire alarm system and who supports it, providing the end user with more flexibility and controls over costs. But in doing so, unfortunately, it means that installed systems can be subject to potential issues by inexperienced engineers. Questions? Here are a few things to consider with equipment. Control panels. Don't forget you may need batteries, zonal LEDs, fuse spur, document box, logbook with your panel, manual call points, replacement glass pack for older systems, hinged protective covers required by BS 5839, section 20.2b and usage sign. Detection. Cans of test smoke or smoke sticks to test your sensors once installed. Spare Apollo Expert addressing cards for when you lose them or come across a double address. Some protocols require handheld programmers to address the equipment. Connections to the internet. In this day and age, we now have the facilities for remote access and notifications. Beams detectors, mounting brackets, additional reflectors and addressable interfaces to make the connection between beam and panel. Wireless equipment. Highly recommend a radio signal survey, as per BS 5839, section 27.2g. Spare key kit and resistor kits. Those small resistors are so easy to lose. And finally, here at ADI, we offer and provide our value-added services. These consist of site surveys, product demos, system design, pre-build and config, commissioning assistance, troubleshooting and training. Here are just a few examples of systems and associated equipment which you may also come across. First, we have a by-wire system, known as a Fike Twin Flex and Apollo Alarm Sense. Next, we have a linear wire system. This is basically a special cable which acts as the detection line. The fire burns through the cable, causing a short circuit, which then generates a fire signal on the control panel. These are commonly found in car parks, underground ducts, and industrial applications. Next, we have some examples of aspirating systems. These are commonly known as Xtralis, AirSense, and Wagner. These systems have a wide range of use from warehouses to computer rooms. Next, we have some examples of beam detection. There are two types of beam detection, end-to-end and reflective. They transmit a small beam of light from one end to the other. If smoke passes the beam light, this is seen as a fire condition. Common units are the fire beam company, which is reflective only, FireRay, which have both reflective and end-to-end solutions, and Xtralis, again an end-to-end system. Remember, these need interfacing onto the main control system and are not standalone. Next, we have some examples of flame detection. These items are by Honeywell and Halma. Remember, these need interfacing onto the main control system and are not standalone. Next, we have some examples of peripheral devices. These items are a little like bolt-ons, which are wired into a dedicated communications port from the control panel, sometimes known as RS485 or RS232. As we mentioned before, input and outputs. On this page, we have an additional LED zone expansion card, 4-way relay card, and an 8-way zone monitor card. Next, we have an example of a smoke detection camera, detecting smoke within a power station. Next, we have an example of a thermal detection camera, detecting heat within a recycling plant. And finally, internet connectivity. There are several solutions for connecting fire systems to the internet. This allows connectivity for both the end user and installation companies to interact with the system for maintenance or compliance. Thank you for your time. Should you require any more information or would like some assistance, then please contact us here at ADI Technical Support. And don't forget to visit our YouTube channel for more information and how-to videos on our vast range of products and services.